Guys, today we're in chapter 7 section 4. We're going to be studying the area of composite figures, which is basically just a bunch of shapes that are all kind of mashed together to make a funky irregular shape. So let's get into this. Let's review first our formulas that we used on other shapes. So the area of a triangle, if you guys need this as a little cheat sheet, because this whole distance learning thing is so crazy. So if you need a little cheat sheet, this is the one that you want to write down. Area of a triangle, that formula is half of the base times the height, or base times height divided by 2. To find the area of a rectangle, that's just length times width, which is the exact same thing as base times height. And then to find the area of a parallelogram, remember a parallelogram is just a rectangle that's tilted, right? It's also base times height. When we talk about rectangles, or when I'm discussing rectangles, a square is also considered a rectangle, because the definition of a rectangle is a four-sided figure that has two parallel sides. It doesn't talk about what their length is. So a square is a four-sided figure with two parallel sides. You have two sides that are like this and two sides that are like this. The difference with a rectangle is that two of them are the same length and the other two are a different length that are identical. So a square is a rectangle, but a rectangle is not a square. All right, so putting that out there. Okay, let's go through some vocab. We're going to be talking about polygons. I may have mentioned these before. A polygon is just a closed plane figure. It's just a shape that's entirely closed. In other words, there's no opening in it where something could get inside. So I think I'm going to show you some examples here. So here is a closed figure, and then this is not a closed figure, right? It's open, something could get inside of it. Okay, closed, not closed. Super simple. All right, examples of polygons. If you guys want to pause this, you could go ahead and do that if you think you need a little cheat sheet. So you know your basic shapes. Of course, a 5-sided figure is a pentagon, 6-sided is a hexagon, and 8-sided is octagon. I will not be going beyond an octagon with you guys. Right now, today, we're talking about 2-sided figures this week, but next week, I believe, we're going to start getting into 3-dimensional shapes. So let's talk about composite figures. Composite figures are just, like I said before, it's a shape that is a bunch of shapes all mashed together. So here we have kind of this rectangle right here. Then we have another long rectangle here. We could divide this in other ways. We could cut this here and make it more like a big square, and then have two little ones, two little squares, or I guess rectangles on the ends. But we can take these composite figures and we can chop that up into multiple shapes to be able to figure out the area of the shape. So when would you use this kind of math? I hear that question all the time. If you are going to be in any kind of art design, you would use this kind of math. I hope you guys recognize this sculpture, or it looks familiar to you. This is a sculpture in, I think it's Sinisippi Gardens down in Rockford. Okay, if you are going to be a builder, a carpenter, an architect, if you are going to be in any kind of construction that has to do with home or building construction, plumbers, electricians, roofers, you are going to use this kind of math. If you want to be a jeweler, you would use this kind of math, or a gemologist. If you want to be in design, fashion design, you will use it. How about car design, designing, working for any kind of auto manufacturer? They are going to use this kind of design process that will include this math. If you want to be a scientist, an astronomer involved in astrology, if you want to be a gamer or a web designer, if you want to work on the internet with coding, you would use this kind of math in developing software and technology. If you want to be involved in any kind of beauty school, if you would like to go into cosmetology, you will use this kind of math. Okay, plumbing, computer graphics. There's so many things that you could use this math for. So where do we see this math in real life? You could see it in a beehive. You could see it in a seashell, these repeating patterns that we study that just naturally occur in life. All right, so, and we would want to take those things occasionally for different purposes and break them up into smaller pieces like we're going to do with these composite figures and figure out exactly what the measurements are. All right, so let's look at this one I have on the screen here. It says you can find the area of an irregular polygon, a closed shape, by breaking it into rectangles, parallelograms, and triangles, which is exactly what I've done here. So to figure out the area of this shape, we would need to figure out the area of this rectangle. Then we would figure out the area of this triangle. And then we would figure out the area of this, I guess it's a rectangle. It looks like a square here, but it's a rectangle based on the measurements. And we would add those three answers together. So let's try this. We're going to find the area of this polygon. So you have two choices. You're going to get the same answer as long as you solve it correctly, no matter which way you do it. So you could divide this polygon. You could put a line right here, and then you would have this big shape right here. Or you could cut a line here, and then you have kind of this square shape here, and you have this rectangle here. So I think what I will do, I'm going to do it on a piece of paper, and I want you guys to hit pause and try this on your own paper. So cut it however you would like. And since we have two quadrilaterals here, right, the formula is going to be base times height for both of them. So cut it however you'd like, and then I'll come right back here in just a second, and we're going to solve this. So hit pause. All right, so I hope you solved for the area of this polygon. I'm going to show you how I cut it. So I put a little line here so that I have this large rectangle over here and this smaller one right here. And I now have my dimensions. I know what the dimensions are for both of these shapes. So this one, the larger one, in the yellow rectangle is going to be 4 times 5, right? Base times height. 4 times 5 equals 20, right? 20 centimeters, because that's our unit of measure squared. The other one is going to be a little bit trickier, okay? This one is going to be 3 times 1, and you might be wondering, how did I figure out that that was 3, that this had a base of 3? Because this whole line measured 7, right? And I know because this is a rectangle that it has 2 parallel sides and two congruent or equal sides. So this whole length is 5. This whole length is 4, which means this yellow section right here is 4. But I need the whole line to equal 7. So that means that this part is 3. 3 plus 4 equals 7. So to find the area of that red rectangle, it's 3 times 1, which means it's 3 centimeters squared. So we add it together. 20 centimeters squared plus 3 centimeters squared gives us 23 centimeters squared. I hope that made sense. All right, I am going to move over to the workbook. So I would like you guys to get your workbooks out and open up to page 408 and 409. Okay, hopefully everybody is into their workbook. You should be on page 408, and I'm going to do a couple of problems with you today just to kind of help get you rolling with this and trying this out. So let's look at problem number 4. You have 2 options on how you want to divide this. You could cut it right here, or you could cut it right here. You're going to get the same answer both ways, assuming that you solve it correctly. So I'm going to cut it, I think I'm going to cut it this way. All right, so now that I have cut it, I have my dimensions for these 2 shapes. So I personally like drawing the shape. Well, that's a little crazy. I like drawing the shape so that I know which one I'm recording the dimensions for. So for this one, it is base times height. So it's 10 times 8, which you guys should know is 80 inches squared, right? And now I have to do the dimensions for this one, which is going to be a little bit more challenging. So because we're trying to figure out how wide is this portion. Well, this is a rectangle, which means it has 2 sets of congruent sides. So this side and this side would be the same measurement. So it is 6. Since this part right here is 6, that means this part is 6. Now we have to figure out how much this is. So this is where it gets a little bit tricky for us. Well, what we do know is the whole length from here to here is 20. And we know from here to here is 8, which means from here to here is 8. So if this whole side is 20, that means 8 plus whatever equals 20. So 20 minus 8 is 12. 12 plus 8 equals 20. That gives us the full measurement for this side. So for our rectangle, it is 6 times 12, which if you guys are using your trusty calculators, and you should be, I have mine over here, 6 times 12 is 72. So 72 inches squared. And then all you need to do is add together these two measurements. So 72 plus 80 is 152. So the area equals 152 inches squared. Okay, let's move over to problem number 8. I just got to adjust my camera here, sorry. All right, number 8 has always been one that stumped students every year. They look at this and they're just not sure where to begin. But once I tell you how to do it, you're going to be like, oh, that's so easy. So what we're going to do is figure out the area for the big green space. The whole thing. We're just going to act like these white boxes are filled in and that this is just one big green solid block. All right, so our dimensions for this, the base is 8. And the height, it tells us over here, is 4. So 8 times 4 equals, hope you guys can do that quick in your head, 32 meters squared. Now we're going to figure out for the little squares, and let's look, do they have the same dimensions? Let's see, 2, it's a square, so it's all the way around, it's the same dimensions, 2 by 2. So for the square, it's 2 times 2, which equals 4. And there are 2 of those, right? Okay, so this one is 4, and this one is 4. So we have a total for these 2 squares of 8, right? So what we're going to do is subtract, since those are empty, they're hollow, and we're just trying to figure out what this green part is. We're going to take 32 minus 4, which is 28, minus 4 more for the second one. So we get 24 meters squared. So easy to do, but it looks pretty, it looks like it's a pretty challenging problem, but it's really easy. So think positive, be confident, you guys can do this, and you'll be just fine. So what I would like for you guys to try is just to give it a whirl and see what you could do. I want you to try problems 6, 7, and 9. 6, 7, and 9. And I don't want you to be too worried about number 9. I know that that looks like, oh, that's pretty intimidating. But it's really not. You've got one big square here in the middle, so you'll find its area. And then you need to look at these these triangles to see if they have the same dimensions. I believe they do. They have the same dimensions all the way around. So you need to find the area of this square and then the area of a triangle, and then just multiply that by 4 because the 4 triangles all are the same dimensions. Okay? So I will put a link in Canvas quiz for you. It's going to be on my distance learning plan too, so you can just click on it right there and enter your answers for problems 6, 7, and 9. And of course, if you guys need me, you can always reach out to me at swolf2@district100.com. Good luck, guys.